Thank you very much for inviting us to this society. Today is a very excellent chance, we believe. And many previous speakers' work is very excellent. But we believe our work also want to contribute to progress the organic flat panel displays field and especially OLED material field. And today's talk is we want to present our work from the chemical companies to the OLED material field. Our Toyo Inc. is continue to supply organic material, especially organic pigment, to the conventional ink. But we also we want to expand our work to the flat panel displays area, for example, car filters and OLED materials. So today we want to explain our work and our policy and our result. Next. Contents. How can we contribute for the flat panel displays? First, contribution for the flat panel displays from chemical companies. And second is performance is of organic materials for OLEDs. And third is application for the OLEDs and summary. Next. Our company is supplied for conventional ink for printing and newspaper and magazines, pigment and the resin and vehicle, and the two disperse for the ink. And conventional printing also we want to work, and electrophotography, like as toner and organic photo conductors, and the various machines also we treat. Especially we Toyo want to supply the color materials for flat panel displays, for register ink for color filters of LCDs, and organic materials for OLEDs. Thanks. And Toyo's chemicals for flat panel displays is as follows. Our Toyo supplied printing materials and optical films and resist ink and test plastics and many colors. So our division of in our companies, we work in fine chemical division, and we focus to make new organic materials like as other compounds and phthalocyanine and quinacridone and optical salts and metal complexes and aromatic amines. Especially we want to make various materials, but our main business is to make copper phthalocyanines, and main interest is to make phthalocyanine materials for many fields. We continue to work to make and to present the field. Our main business is to make phthalocyanines for the pigments, pigments. But new business we want to focus to progress for OPC, organic photoconductor, solar cells, CDR dyes and OLEDs, and photo initiative. This is our preparation of copper phthalocyanine for OPC. This is one example. If we want to copper phthalocyanine OPC grade, we treat several steps, chemical and physical treatment, so we can get the new crystal form of the phthalocyanine with high photoconductivity and low dark conductivity. We can change the crystal structure and high purification technique. And this is one example for CDR dyes. This is molecular design of phthalocyanine. The first step is to make to select metal source, and this is a selection of quality of basic properties. And second step is as follows. And this we select the matching of wavelength absorption for IR area. We selected this substrate. And third step is to add the solubility of solvent. So we select the aqueous substrate, or various kind of substrate we select. So we finally can get the excellent CDR absorption dyes. This is a production of phthalocyanine for the OLED. This is a normal, usual cup of phthalocyanine. We select several steps for the high purity grade cup of phthalocyanine, or to use several purification system for the difference of to use the difference of solubility. And second step is to use the difference of thermal characters for sublimation. We want to get a high purity material, so we select several steps of for purification, so we can get excellent cup of phthalocyanine for OLED grade. This is example properties of CPC or for OLED. Excellent. This is one example synthesis of quinacridone pigment. Quinacridone is very famous pigment for red pigment, but in OLED area field, this quinacridone pigment use green emitting material. This is a chemical route. We can select several route. And this also new. If we want to select the new function of quinacridone materials, we can control the new chemical route for the solubility and for fluorescence and wavelength change. This is one example, very famous metal complex ALQ3. And this is a chemical route of some complexes for all red. We can select the starting materials. Of course, these materials need high purity. So several we synthesis the several to use several steps and to add the aluminum or other metals. We can easily use metal complexes for the electron injecting materials with high efficiency. Yes, high efficiency. This means high mobility and high injecting properties. This is a result of our materials. Same chemical structure, but different characters. We can get the high performance HQ3 material also. This development new function of basic structure, organic materials. We need to supply for the customers for the colorant of the pigment, but we want to select and several characters for the research and development. And new function. New function means to supply front display or OLED field. This is and I want to talk with OLED materials. with multi-layered OLED. These organic materials we want to supply, and we want to research the organic layers. Organic layer means whole injecting layer, whole transporting layer, and light emitting layer, and electron injecting layers. A research program for and to continue for 10 years. This is a program of all LED devices and the characteristics of devices and full color program and manufacturers for OLED panels. This program is continued to make excellent flat panel OLED panels. We want to supply new materials for excellent high purity materials for OLED field. So materials, dopant host materials, and metal complexes, whole electron injecting materials and host materials, and aromatic amines is this whole injecting or transporting materials or host materials. This is our marketing and design system, synthesis, purification, and we continue to rotate for the development. Next. That is our instruments. So the standard material, basic OLED material, we want to supply the new materials, but in the first stage we want to expand, supply the excellent improved materials or three very famous materials. The focus is this metal complex, more higher electron mobility, or higher electron injecting characters, and higher thermal resistance and higher hole mobility and transparency program. We need to change the materials. This is the bar structure of OLED, and this is whole injecting layer. And use these materials, and the function is this. If we get improved OLED materials from the material is need these characters to make the thin film, high hole mobility, and electrochemical stability, ionization potential, thermal performances, and thermal stability. This is an example of hole injected transport materials, phthalocyanine compounds and aromatic amine compounds, and other structures also present for many researchers. This is an example of thermal stability use. To change the X part, we can easily get high thermal resistance materials. This is an example of Toshio Inc.'s original HIL instead of CPC. This red point material is aromatic amine materials with high excellent properties. Of course, this is high transparency materials. So this red emitting, in the case of red emitting devices, very excellent characters. And this is a molecule design for whole transporting materials. In the case of aromatic amines, this is basic parts of polyphenol parts, and we add some connecting parts For example, T-PAC, for example, FTPD. So we can get the flexibility and thermal stability. This is summary of FTPDs. We can get these materials, so high TG and properties. And this is a second trial for the tryphenylamine derivatives. And one is this is basic structures and to get a cyclohexyl group. So to connect the cyclohexyl group, so we can get the high TG materials and the same ionization potential. So this is T-PAC materials. This is a usual tryphenylamine pack and the cyclohexyl group. So this N number N is 6 or 7. This is the oligomer of tryphenylamine. So we can use like as polymer OLED materials, and both systems we can easily use this material. This is light emitting layer. This is function and materials. For the light emitting materials, we need high emitting efficiency, high maximum light emitting intensity, color purity for full color display, and emitting life and safety. This is very famous typical light emitting materials, and host materials, and doping materials. And those materials is hole transporting host and electron transporting host. And doping color is like this. This porphyrin type materials is red emitting materials. This structure is Toshio supplies these materials. And color, of course, color program and light program is very important, but from the industrial point of view, doping system and non-doping system is very important program. Doping system is usual system for the host materials to dope the light emitting materials to present very excellent properties. But doping system is very difficult to control the mass product system. If we present non-doping system materials, non-doping means don't use dopant materials. One materials is emitting. One materials has emitting parts and hole or electron transporting parts. Both parts is used in one molecule. We want to research and want to supply new non-doping materials for red or blue color materials. We can supply the blue, green materials for over 20 candela. Efficiency is 20 over materials. We can supply that. And most important program is to supply the red light emitting materials. This is a program of red emitting materials. If we use a high current region, this density, the lifetime is decreased. This is one example of red emitting materials. this is some makers, some researchers select our substrate, so EL peak is changed in this way, and if we use the change the dope host materials will change. This substrate is excellent, but this whole transporting host, if the whole transporting host is used for this dopant, this substrate is very excellent properties. So one doping materials is changed. Other kinds of host materials. This is a very famous example of doping system and host dopant, EA dopant and dopant. This is a very famous system, but the color and efficiency is not so good. So we want to answer this problem. This answer is to supply the high performance host and dopant materials. So we can get long life, long emitting time, and low driving voltage, and high color purity and high emitting efficiency materials. We can present the field. And this is Toyo's present red emitting materials is over, this color purity is over 600 and this is very excellent luminescence current density curve. This is the last layer of electron injecting layer. This is the function and the material problem. Electron injecting material also to the some characters are very similar to the hole injecting, but electron injecting material is very to make a new, excellent electron injecting material is very difficult to make. Probably it is, we cannot select excellent basic structures for the electron mobilities. This is a typical electron injecting materials, metal complexes and heterocyclic aromatic materials. We Toyo Toyo supply the excellent electron injecting materials. And this green line is to use alpha NPD for hole injecting, for injection, and towards greens. This non-doping materials, and to use ALQ3 for EIM. And if we change the EIM, Toyo's EIM, this is a character. Red is a character. Very low voltage devices we can select supply and excellent properties. So we Toyo want to contribute for the flat displays from chemical companies. We present the materials of commercial size scale for the flat panel displays. And second is performance of the organic materials for OLEDs. This is synthetic and purified technologies of organic pigments was applied to the flat panel display by Toyo Inc. Application for OLEDs. We present high performance of organic materials for each layers in the OLED field. Of course, not only Toyo Inc. Many chemical research supplies improved chemical for the future of fruit punch display was. Thank you very much for your attention.
Thank you for a nice presentation.